Okay, this is Algebra 2, Lesson 28. We're going to start by talking about the denominator-numerator rule. We learned earlier that if you multiply the numerator or denominator by the same non-zero quantity, it doesn't change the value of the fraction. For instance, 1/2. If I change it to 3/6, I haven't really changed the value. Basically, how I got here is I multiplied this by 3 and this by 3. So I've multiplied it really, truly by the number 1, because 3 over 3 is the same thing as 3 divided by 3, and anything divided by itself is 1. So basically I'm multiplying 1/2 times 1. It just looks different. So knowing that, we could do the same thing with a variable, a over b plus c over d. So if I multiply this by d over d and this by b over b, I'm not changing it. Now we can actually add these. There's a plus sign here. Kind of got covered by that. So I have AD plus CB all over BD, because they're the same they both have the common denominator. So just flip. Remember, my commutative property says I can do that because this means multiplication. So it's the same thing. So now I've got AD plus CB over BC. All right. We also use the denominator rule to help simplify fractions of a fraction. So let's look at this one. A over B divided by C over D. We learned if we multiply the numerator and denominator by the same thing, it's still 1. So even though this is a fraction over a fraction, think of it as a number in the numerator and another number in the denominator. Think of this as your fraction bar. And we said if we multiply any number by its reciprocal, we get 1, right? So if we do that to the denominator, then we must also do it to the numerator, because DC divided by DC is simply 1. So this cancels, and you get 1 here, and you simply have AD over BC, which is the same thing as just AD over BC. So we're still using our same rules. They just look different, that's all. So the denominator-numerator rule can be used anywhere, at any time, on a term in an equation, or on a term that is not in an equation. In everyday language, we can say anytime, anywhere, the denominator and numerator of an expression can be multiplied by the same quantity that's not 0 without changing the value of the expression. Only the form of the expressions change. So we've just renamed it. We haven't really changed it. We've just renamed this. Okay, so let's look at, and this goes through and use the word simplify. So let's look at this next one. Simplify A over B divided by x plus y over b. So this is your denominator and this is your numerator. So we said we want to get rid of the denominator, so I want to make it 1, so I multiply by its reciprocal. Doesn't matter what it is. You multiply any fraction or any number by its reciprocal, you're going to get 1. So what we do to the denominator, we must also do to the numerator. Remember, you put parentheses to know that these are married until you distribute through. So this simply crosses out, yes? And you're left with AB over B times x plus y. Because of the multiplication, this crosses out, and you simply get A over x plus y. And you can't simplify any further than that. So let's look at example 28.2. You have A over A plus B divided by C over A plus B. Again, we want to get rid of this denominator, and how do we do that? We multiply by its reciprocal. It's just a complicated reciprocal. It's still just, oops, yes, a fraction. And what we do to the denominator, we must also do to the numerator. So this goes away. This cancels, and you simply get A over C when you simplify it. Do you see that? That's all it is. So don't get frazzled because it's complicated stuff. It's really not. It's still just a fraction. You just got to know that when you have a plus or minus, that this, I would say, in a sense, is married to each other until you can distribute all the way through. As long as it's in parentheses, and you've got this needs to be c times that and c times that. As long as it's multiplication, this whole thing, if it's the same thing, it crosses out. Now, if I had c plus 1, well, I could no longer cross that out with this because it's not the same thing. It's something totally different. But it's not, so I was able to do that. So let's look at the next example. And the next example talks about rationalizing the denominator. So let's look at this expression. We all have to see this. Okay? We have a what? A radical in the denominator. Many people like to change the form of these expressions so that we don't have a radical in the denominator. We like to not have it in the denominator. So what we could do, how do we get rid of that radical sign? Yes? And isn't this over this equal to 1? Yes, it is. But this now becomes what? 7. Because isn't the square root of 7 times 7? There's 2. You take 1 out, it becomes just 7. And then you have 4 square root of 7. We didn't change it because we multiply by 1. Isn't anything divided by itself equal 1? So we multiply that times this, right? Multiply that times that times that, and gives you 7. You got to know how to multiply radicals. If you don't, then you're going to have a problem here. And if you need help with that, let me know in class or outside of class, or call me or text me, and we can go more in depth with that. But basically, it's like putting them under the same radical sign, 7 times 7, and to get the square, you have to have 2 to take out, and you can. All right? When we do this, it says the new expression has the same value as the original expression, but the denominator is now a rational number instead of an irrational number. This procedure is called rationalizing the denominator. Make sure you write that down in your notes. Rationalize the denominator. Okay? Instructions for these problems will simply tell you to simplify. And let's look at the little box here. It says an expression that contains square root radicals is in simplified form when no radicand has a perfect square, so this number is not a perfect square factor, and no radicals are in the denominator. You have no radicals in them. So if I had say 6. Okay, I want to get rid of my denominator, so I'm going to do this. Yes? This becomes 6 all over square root of 20 times 6. Well, I have some perfect squares because if I factor this out, I get 4 times 5 times 2 times 3, right? And in this, the perfect square, I can take that out, which leaves me 2 times this over that. That's in simplified form. This is not. Square root of 120 over 6. That's what they mean about a perfect square in the square root, whether it be in the numerator or denominator. And you can't have a radical sign in the denominator. Then it's in simplified form. So let's do some more problems like this. If we say 3 over 2 square root of 5. Well, I just want to get rid of that square root of 5, so I'm going to what? Multiply the numerator and the denominator by square root of 5, because I don't want a radical sign at the bottom. And I simply get numerator times numerator. You can't forget your rules for multiplying fractions. 2 times, take this out, becomes 5, or simply 3 square root of 5 over 10. It's as simple as that. Let's do the next one, 28.4. You have 2 over 3 square root of 12. Well, you can do one of two ways. Let's do the first one we know. Let's go ahead and do this, right? Because we want to get rid of the radical sign at the bottom. So this becomes 2 square root of 12 over 3 times 12, which is equal to 2 square root of 12 all over 36. Now you can reduce to 1 over 18, or simply square root of 12 over 18. But wait a minute, we have a perfect square in here. Isn't this square root of 4 times 3 over 18? Yes, it is. So we can take out that 4, or actually take out a 2, because that's 2 times 2. Square root of 3 over 18, and simplify, then you get square root of 3 over 9. So remember, it's not simplified if you have a perfect square under the radical sign. Doesn't matter if it's a numerator. You still got to factor it out, or square root it out. If you forget how to do square root, 12 is 2 times 2 times 3. You have to have a pair. You take that out, and what are you left with? That's how we got this. Okay? So your code for this lesson is put the number 627 on the top of lesson number 26. 627, top of lesson number 26. Do your practice problems, and if you have any questions, you can call me or text me.